Okay, let's talk about the properties of logarithms. But first, just a quick refresher here. If I have a equals b to the x power, and I want to rewrite this expression as a logarithmic expression, what you do is you start with the base here, b, and hook it around. So that would be log base b of a equals whatever the power is, x. So these two expressions are the exact same expression, just written differently. Think of this, you can write 4/16 or rewrite that as 1/4. So I can rewrite these expressions differently. Just like in the properties of logarithms, a equals b to the x is the same as log base b of a equals x. So with that in mind, let's go over the first properties of logarithms. The first property of logarithms is log base b of 1 equals 0. So let's think about why that would be true. If I were to rewrite this logarithm as an exponential expression, it would be b to the 0 power equals 1. And we should know that anything to the 0 power always equals 1. So let's do an example. If I have log base 1, that will be 0. If I have the natural log ln of 1, that will equal 0. Remember that ln represents log base e of 1. Okay? Or if I have log with no base written of 1, that equals 0 as well. Log with no base written means log base 10 of 1. So it doesn't matter what the base is. If 1 is in this position, the whole expression will always equal 0. The second property of logarithms is if I have log base b of b, that is equal to 1. Let's see why this one would be true. If I rewrite this as an exponential expression, I get b to the first equals what is on the inside here, so that would be b. Is b to the first equal to b? Yes, that's true. So this property of a logarithm would also be true. Let's look at an example here. If I have log base 4 of 4, that will be equal to 1. Or if I have log with no base written of 10, that means log base 10 of 10, that will be 1. Or let's do the natural log. If I have the natural log, which means log base e of e, that will be equal to 1. So if the base and what is written in this position are the same, then the whole expression is equal to 1. The third property of logarithms says if log base b of b to the x, it equals x. So let's look at why that would be true. If I were to rewrite that as an exponential expression, it would be b to the x equals b to the x, which is true, which makes the property number 3 true. Some examples here. If I have log base 4 squared, that would equal 2. And I like to think of this as log base 4 canceling out, because we have a logarithm canceling out an exponent, which leaves you with the power. The next one, let's look here. If I have log base 3 of 81. Now we can rewrite log base 3 of 81 as log base 3 to the 4th power, because 81 can be written as a base of 3. So log base 3 to the 4th power would equal 4. Let's look at just a couple more here. If I have ln e to the 7th power ln, and ln means log base e, so the e's cancel out, and we have that equals 7. Alright, one more here. If I have log of 1 over 100, remember log with no base means log base 10, so this really can be written as log with base 10. I'm not going to write that. And then 1/100 can be written as 10 to the negative 2 power, so that would be negative 2. So whenever your log has a base, and then whatever's in this position, the 10 here, they cancel out. So just remember that, and then you end up with whatever the power is. Alright, the fourth rule property is in a little bit different form here. So the property says if I have b to the log base b of x power, that equals x. Now this is actually the same property as property 3, just in a different form. So we have here, if I were to take this expression, b to a power equals x, and rewrite it as a logarithmic expression, I would have b to the x. So I would go log base b of x equals whatever the power is here. And the power is log base b of x. So if I have that, those are definitely equal to each other, so that means this property works. So let's look at an example here. If I have 5 to the log base 5 of 10 power, that would equal 10. Or if I were to have e to the ln of 4 power, the e and the ln are the same, have the same base, so they cancel out, and we'd end up with 4. So there's just a couple examples of how that property works. It's actually one of the few properties we don't see a whole lot, but it actually still works, so that's why we look at it. Now let's take a look at some of the expanding and condensing properties here. We have number 5 says if log base b of m times n is a property, then, or is the expression, you can break up that into addition. Log base b of m plus log base b of n. So let's think about if I had b to the m power times b to the n power. This right here is what this logarithm is saying, m times n, the powers. You can break that up, or you can combine that together, as adding the powers. So you just add the powers. Okay, so if I had log of b 4xy, something like that, you can break that up as log base b of 4 plus log base b of x plus log base b of y. So you can break that up. You can actually also condense it if you wanted to. So if I had log base, we'll just keep base b, of x plus log base b of x plus 1, you can bring these together because I have each group with the same base as log base b x times x plus 1. Okay, this rule goes hand in hand with rule number 5. If you have log base b of m divided by n, instead of adding the pieces, you subtract. Okay, so, and the reason is if you had a to the m over a to the n, you would subtract the power. So that's why that works. Okay, so if I had log base 9 of 81 over x, we can simplify this expression here as log base 981 minus log base 9 of x. Now the cool thing is about this is I can simplify this expression even further. Hold on. Alright, this equals log base 9 squared. So this can reduce to 2 minus log base 9 of x. Now you can do the same thing we did previously. So you can go and condense them, or you can expand them out. Either one. The last rule of property of logarithm that we're going to look at is the power rule. So if I have log base b of m to the p power, we can bring the p out in front. Okay, so if I had log base 4 5 to the 10 power, and we want to figure out what that is, you just bring the power out in front, and it would be 10 log base 4 5. It simplifies to that. Also, you can go the other way. If I have 2 to the log x, and I want to rewrite this so that it's all in the form of a logarithm, I can bring the power up. Log of x to the second power. So those are all the properties of logarithms that we're going to look at. There are a couple more. For example, there's a change of base formula, and there's one to help you solve equations. But these are the 7 basic properties of logarithms.